Okay, so does anyone remember increasing? When is a function increasing? How do we know when a function is increasing? Let's start with that one. How do we know when a function was increasing or decreasing? Because it's really very similar. They're both very similar to tell. How did we tell? When not f of x, there you go. When f prime is positive, good. So when f prime of x was positive. When the slope of the function is positive, it has to be increasing, right? Slope means going uphill. So if it's positive slope, it has to be going uphill. So conversely, how did we tell when it was decreasing? Hmm?
When it was below 0 or negative.
When what was? You're right.
F prime of x.
There you go. F prime of x was less than 0, negative, right? If a slope, because f prime is a slope, was negative, it could only go one way, downhill. Okay. What happens in the middle? So we have positive, we have negative. What's in the middle of positives and negatives? What happens then? Hmm?
Concave.
Not concave. Yes, Sebastian? Yeah, so when f prime is 0. So which one of these, so we have f prime is 0, right? Which one of these is going to be f prime of 0? Because we have it when it's positive, we have it when it's negative. What if when f prime is 0? Hmm?
It's a critical value.
It's a critical value. What happens there as well? Keep going. Not an inflection point. It's close. That's second derivative. There's going to be a relative minimum or maximum. We just don't know which one, right? But what else is going to be there? It's one of these guys here that we haven't filled out. There you go. There's a horizontal tangent line, right? That means the slope is 0, right? So f prime is 0, which is a critical value, which is also going to be a relative maximum, relative minimum. That's definitely true. We just don't know. We have to be more specific. So the next one is relative maximum and relative minimum. Okay. So I know it's going to be when f prime equals 0. But how do I know if it's a maximum or minimum? What tells me if it's a maximum or minimum? What tells me that? Like if it's a maximum, I know f prime is going to be equal to 0. So it's one or the other. How is it maximum? What makes it a maximum? There you go. It changes from increasing to decreasing. And what did we say increasing was? We said increasing was when f prime was positive. So it switches from positive to negative. It switches from increasing to decreasing, increasing and then decreasing. That creates a relative maximum. Okay. So what about a relative minimum? Where is that one going to be? There you go. Yep. Everything's the same except it switches from negative to positive. That's a relative maximum. Or sorry, minimum. Good. Okay, so that's the first derivative stuff. We're done with the first derivative stuff. Now concave up, concave down, points of inflection. How do we know when it's concave up? How do we know when something is concave up? Yeah, you ready? There you go. Now we're talking second derivative is positive. Good. Concave down? There you go. Second derivative is negative. Good. And then how do I know where it switches from points from concave? That points of inflection are where it switches from concave up to concave down or concave down to concave up. So how do I know when is it going to switch? When f prime is what? 0. Mhm. 0. Okay. Again, all of that stuff is review. There were tests that you guys had where you guys had to give these as justifications. Okay, so they're somewhere in your notes. You've done them, but today having these in front of you is going to help tremendously with what you're trying to do. Because I've done this without this list, and I've done it with the list, and it's a lot easier if it's right in front of you at your fingertips. Okay, because they're going to ask us the first question right here. Where is G increasing and decreasing? Okay. So it helps to know. So the first thing I'm going to do, you see how they do, you see how the first question I need to do, what is it? 6b, it's a G. I'm going to switch all my F's to G's just to fit this question. It's the same thing. They just chose a different name. But it's going to help me with solving these. So if you're doing a question on your homework and they switch it to H, switch them to H's. They switch it to F's, switch it back to F's. But I always try to match it with the letters I'm working with because it just helps me see because you're going to run into a lot of different letters and it helps you keep it straight. Okay? Still means the same thing. Just instead of the function's name being f, now it's going to be g. Does the same exact thing. Okay. Okay, so what are the intervals? What are the intervals on which g is increasing or decreasing? Okay, so let's go back to our list. G is increasing or decreasing when the derivative, oops, erase the derivative part on decreasing. The derivative is positive or negative. The derivative is positive or negative. Okay, so let's go back to G. We need to know when G prime is positive, and we need to know when G prime is negative. That's what we need to know. That's going to be our justification. Why is it increasing? Because G prime is positive. Why is it decreasing? Because G prime is negative. Okay. First thing we need to do is go back to G. What is G? G is this whole entire thing. G is this whole thing here. G is a integral. It's finding area under the curve. Okay. If I were to find the derivative of that, what would it give me? Let's see if we remember from yesterday. If I were to find the derivative of that guy there, what would it give me? Yeah, that's exactly what it would do. Remember yesterday, the first couple problems we did? When we had the derivative of this guy, when you have the derivative of an antiderivative, all that happens is this guy here goes right there and becomes f of x. And guess what? That graph right there, it's the same thing as that graph right there. I just changed the letter. Okay? So this right here is a graph of what we're looking at. Okay? So let me write this down. G prime is the same thing as f of x, which is the graph. So I'm going to look at the graph to see where it's increasing and decreasing. Okay? So where is the graph? Sorry, not increasing, decreasing. Where is the graph positive and where is it negative, right? That's what I'm doing here. If I need G prime, it's the same as the graph, right? So instead of G prime, you can just say, when is the graph positive? When is the graph negative? Okay, let me color code it. The graph is positive here, negative everywhere else. Okay, because G prime is the same as the graph. Okay, G, we did the table for G already. G itself is actually an integral, which is area under the curve. Okay, so now what we're going to do is we're going to write the intervals where it's increasing or decreasing. So increasing, yellow. So from -3 to -2. Decreasing. So when it's decreasing is a little different. Okay, so decreasing. I've seen it written two different ways. Now you can see that the purple is all you can see the purple is all in the negatives, right? So sometimes, and I think Delta Math does this, they'll say, okay, everywhere from -2 to 3, because that's where it ends. And I've seen some do it this way. They say, hey, at 0, it's not actually negative, it's 0. So you can't put that there. So it just depends. Now, on a multiple choice test, you won't have both, right? So if Delta Math marks you wrong for that, change it to this. Or 0 to 3. Technically, the right answer is the second one, because it is 0 here. Here it is 0. 0 is not negative or positive, it's 0. So we shouldn't include it in our, right? But I think Delta Math does it like this. So if you put this answer in and it marks you wrong, change it to this answer here. Okay. On a test, it'll most likely be like this. This is what I would write. This is what I would write on a test, because it's true. But I've seen some books that say, hey, everything under the line, they consider that under the line. Okay. And then justify each response. Well, here you go. That goes with that guy. That goes with that guy. Because G prime is positive. Because G prime is negative. Okay. That would be your justification. Okay. Okay. So let's go to question C now. Question C. I think you got to flip it over. So you got to flip it over. So I made a new table. It's the same table. So just fill in the table from what we did yesterday. It's the same table. I just made an extra table because I knew you were going to have to flip it over and you might not see it. So it's the same exact table as you did yesterday. It's the same values, same graph, same everything. Okay. I'm going to erase this because it's a different question now. Okay. What are the intervals of G on which G is concave up and concave down? Okay. So referring back to our cheat sheet here, we know that when G double prime is positive, concave up. When G double prime is negative, concave down. That's going to be our justifications. Okay. So G double prime positive, G double prime negative. That's our justifications there. Okay. G double prime. We know that G prime is the same as the graph. right? We know that from the last question. So what is G double prime going to be? What is G double prime going to be? The derivative of the graph. So in other words, if it's going to be the derivative of this f of x, what is that? What am I looking at then? I'm not looking at values. What am I looking at? Slopes. So now I'm looking at slopes on the graph. Okay? So let's write that down. G double prime equals f prime of x, which is slopes on the graph. Slopes on the graph. So now a positive slope is going to be G double prime being positive. A negative slope is going to be concave up or concave down. Okay? So I'm going to go highlight, I'm going to go look at the graph where it's got a positive slope and where it's got a negative slope. Okay? So positive slope is right here. Everywhere else is a negative slope. Okay, so yellow is a positive slope, purple is a negative slope. That's where G prime, double prime, is going to be positive and where G prime is going to be negative. Okay, so let's start with positive. It's got a positive slope on the yellow. The yellow is from -1 to 0. Okay, so concave up from -1 to 0. Because, and then I'm going to move this guy right over here. G double prime is positive. Okay, concave down. Concave down is everywhere else where it's purple. So from -3 to -1, and then from 0 to 3. From -3 to -1, or 0 to 3. Because G double prime is negative. Okay? Because that's where the slopes are negative. That's where the slopes are negative. That's what I'm looking for. Right? That's what I'm looking for. Okay. All right. So now, relative max, relative min. Move this up a little bit. Oops. Okay, so relative max, relative min. Let's go back to our list. What defines a relative minimum? What defines a relative maximum? Relative minimum is when the relative maximum, relative minimum is when the what happens? What happens there? Exactly. So we're going to refer back to not the slopes of the graph. We're going to go back to this guy right here, G prime, right? Relative maximum or relative minimum, sorry, G prime switches from negative to positive, right? That's a minimum. Maximum is where G prime switches from negative, Oops, the other way around, to positive. Positive to negative, sorry. So minimum goes with the first one, maximum goes with the second one. Let me change the colors so that makes a little more sense. Okay. G prime refers to the graph. So I'm not looking at slopes right now. I'm just looking at where the graph switches from negative to positive. Okay, so here's the graph. So where does the graph switch from negative to positive? Let's see, from -2, it does a switch, right? At -2, there's definitely a switch there, right? It goes from positive to negative. There it goes from positive to negative, right? It comes from the positives and goes down to the negatives. So there's a switch there. That's important. So is that going to be, is -2 going to be a relative maximum or relative minimum? Maximum. It's going to be a maximum, right? So that's a relative max. Okay. Anywhere else, I'm going to have a relative maximum or minimum. What about 0? We get a lot of people putting 0. 0, right? That guy right here. Is that a maximum or minimum? There you go. It doesn't switch. Yeah, it doesn't switch. It's going up and it's getting right to the border there, but it doesn't cross. So because it doesn't cross, it's not a relative maximum or minimum. Okay? So the only one we have one relative max, and it's at -2. Okay, so let's go write that down. And then because, and then no relative minimum. Okay. All right, one more. Actually, two more. One more with that, and then the last one is not too bad. Inflection points. Inflection points. Okay, let's go back. Inflection points happen when G double prime is 0. When G double prime is 0. Okay. Well, G double prime refers to the slopes on the graph. So when are the slopes on the graph 0? So go look at the picture. When are the slopes on the graph going to be 0? Is there anywhere where the slopes are going to be 0? Because you have a negative here, right? We have a negative slope here going downhill. Then we have a positive slope. Then we have a negative slope, right? So these points here are not 0, right? They're more like undefined, but they're still considered critical values, right? They're still considered critical values. So I would say -1 and 0. -1 and 0 are where, because it's switching, it's technically switching from negative slope to positive slope to negative slope. Even though these guys don't have a nice horizontal tangent, they are undefined slopes, and we still consider those critical values. Okay, so at -1 and 0. because slopes are undefined. Or I should say G double prime is undefined instead of slopes. G double prime is undefined. Okay. The last thing you're going to do is graph G of x. Make dots, graph it, see what it looks like. You have dots, you have points, right? You have points from the table. It's the same graph you had before. Graph the thing, see what it looks like. Okay. So the graph kind of looks like this. G, this is G. This is the graph of G. Okay. So the derivative of this graph is this graph here, right? That's the derivative. Because if you look on this graph, you can see that from 3 to negative 2, it's got a positive slope. And then at 2, it switches to a negative slope. That's why at negative 2, it switches from positive to negative. And then at 0, it kind of comes up to the border, but it doesn't quite do anything. Well, you can see at 0 here that it's kind of coming up, it kind of slows down, but then it continues going, decreasing. That's why. Okay, and then it just decreases after that. All right. Okay, so now what I'm going to do is I'm going to give you some practice problems. What do we got? 3 of them in here? No, a few. Let's do that. Let's do one at a time. So let's go number 7. I want you to do number 7 on your own. I'm going to give you about 3 or 4 minutes. Do number 7. Okay, so increasing here. G is increasing, right? So they use the same letters as before, so G will keep with it. So G prime is the derivative of the integral. The derivative of an integral is just this guy right here, just with a different letter in there, so x. And guess what? The graph is also f. So we're just looking at the graph. So literally all I'm looking for is where, this is going to be my justification, right? Because G prime is positive, right? So essentially what I'm doing is looking for where f is positive, because G prime and f are the same exact thing. These guys are the same exact thing. So essentially what I'm doing here is I'm just looking for where is f, where is the graph positive. Okay. So the graph is positive here, stops being positive there, positive, positive, and that's it. So from -9 to -5, or -2 to 3, because f prime is positive. Or sorry, G prime. Sorry, G prime is positive. Okay. All right, do number 8 now. If you haven't already, do number 8. Point of inflection. Okay, so point of inflection. Point of inflection is where G double prime is 0, right? G double prime is 0. Okay. Well, if G prime is F, G double prime is going to be the same thing as F prime. Because G single prime was the graph, F. So G double prime is going to be F prime, which are the slopes, right? Which are slopes of the graph. Slopes of the graph. So we want to look to see where the slopes of the graph here are 0 or undefined, right? 0 or undefined. So let's see, the slopes are positive, 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 and then it kind of goes negative. So looks like here, right? And then here, it's another undefined, right? Because it's decreasing and then goes up. So we're looking like right there. And then one more up here, right? So we're looking like there's 3 points of inflection at x equals 1, x equals 3, x equals 7. Okay. Because G double prime is 0. Okay. Okay, so the last thing we're going to do today, we're not going to finish this today. So tomorrow we'll finish these notes, and then I'll give you some time to do the assignment in class, to work on the assignment in class. I'm not going to assign anything new today. So the last thing is now this guy here. Given the function f of x, so now they're changing it to f. Okay. F of x equals the integral from -1 to x, 2t to the 4th minus 8t cubed minus 24t squared. Okay. Determine all the x values, if any, for which f has a horizontal tangent line. What's different about this one? There's a couple different things about this one than in the past. What's different about this one? What's the big difference between this one and the ones we've been doing since the beginning of class today? There's no graph. There's no graph. Do they make up for it though? What do? They give us an equation, right? Okay, we can use that. Good. What else is the new thing? There's one new thing also that we haven't seen today. Yeah, Ram? Yeah, even though, here's the thing, it might seem silly. It's just G to F. It's still big because, trust me, guys, it's hard to keep these G's and F's and all of these things. It's hard to keep them all making sense in your head, right? So the little things, it's definitely the little things. Okay? So yeah, definitely. The other thing that I saw too was horizontal tangent line. They haven't asked us for a horizontal tangent line yet. Okay, but we know how to do that, right? When is a horizontal tangent line? When are we going to have a horizontal tangent line? When are we going to have a horizontal tangent line? When? Say it again. Say it louder. There you go. Yeah, f prime. We have it g prime in our notes, but it's f, so is 0, right? So that's what we're looking for. When the derivative of that guy equals 0. Okay. how do I find the derivative of this guy here? How do I find the derivative of this guy here? That's the short way. Yeah, the short way is, hey, it's just going to be the same guy. It's just going to be the same guy, but with instead of t's, it's going to be x's. That's the short way, right? The long way is actually find the antiderivative of each of these guys, plug in x, plug in -1, subtract them, right? Just like we did in the earlier part of the notes yesterday. The only difference is, and then your answer is you're going to end up with a bunch of x's here. It's going to be 2x to the fourth minus 8x cubed minus 24x squared. Okay, that's essentially what's going to happen. So we're going to get f prime equals 2x to the fourth minus 8x to the third minus 24x squared. That's essentially what's going to happen when we do that. Okay, so my directions say when that guy is 0. So set it equal to 0. It's a trinomial. It's got 3 terms. How do I solve a trinomial? Well, the first thing is set it equal to 0. Done. Second thing is factor out. Do they have it? Is there a GCF between all 3 terms? Yeah, I can divide them by, what can I divide them by? 2, and what else? X squared, good. All right, so I have 2x squared, and then I have x squared minus 4x minus 12. Okay. The next thing is factor. Depending on how your teacher taught you, there's different ways to do the factor. Like you can do the x, right? Most teachers teach some version of this guy here, where you multiply a is 1 times c, -12 and -4. And you're looking for 2 numbers that multiply to be -12 and add to be, or multiply -12, add to be -4. Let's see, what would that be? 6 and 2. One of them's got to be negative though, so -6. So you get x minus 6, x plus 2. Equals 0. Then you set them all equal to 0. You have 3 things you need to set equal to 0. You have 2x squared equals 0. You have x minus 6 equals 0. You have x plus 2 equals 0. You did this in math 2 and math 3. I know for a fact because I'm teaching it right now, right? We just passed this part in math 3. So you've done it before. You just haven't done it in a while in this class. So here, you're going to divide by 2. Take the square root of both sides, and you get 0. Over here, you're just going to add 6 to both sides. Over here, you're going to subtract 2 from both sides. So you get 3 answers: 0, 6, and -2. Okay, so let's go back up and see if that makes sense with what we have. Determine all x values for which it has a horizontal tangent line. At x equals 0, at x equals -2, and at x equals 6. Because f prime of x is equal to 0. Okay, done. So it's the same thing, you just use the equation instead. Okay? Okay, so we got about 5 minutes. I'm not going to go on. We still have 2, 3 more problems left. And yeah, Roman?
Oh, I was just gonna ask, how could a horizontal tangent line be at -2 when the bounds are
Oh, yeah, that's a good question. I didn't even look at the bounds. Thank you. Where are the bounds? -1 to whatever, right? Could I have all of these guys be bounds? So this one stuck out to you, Roman, right? This one stuck out to you here. Oops, where is it? Right here. This guy, right? Why is it not doing that? This guy right here, right? Could that still be a bound? Yeah, we would just need to flip it. Yeah. 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 So if we were to put -2 as a bound, I don't know why it's not letting me write. But if we were to put -2 as a bound up there, we could do that. We would just need to flip the bounds, right? So yeah, that's a good question to ask, though. That's always a good question to ask because you always want to make sure the answer makes sense. Okay, good. All right, guys. Okay, so we'll finish the rest tomorrow. The next one is very similar, so I'll probably have you guys start with that one tomorrow, and then the last two we'll do in class, and then we'll be done with the chapter. Like I said, notes will be very short tomorrow. The rest of the time, I want to give you to do the assignment. Ask questions if you have questions on the assignment. Okay.